Okay, so let's start the session. So last 4 5 sessions we went through the transformations. Then we'll understand write API, and then other read APIs also will understand, because we started with the JSON, CSV. Similarly, we'll understand other formats. But before starting other formats, first what we'll do, we'll understand write API, how we can write the data and the different options. Okay, then Delta Lake. Maybe next week we'll start the Delta Lake. Okay, so let's open the notebook. Let me clear the cell output. Okay, let's create a data frame. Consider this is a final data frame. Okay, just we are using a limit. So this is the total data, because we selected only a few columns from the existing data frame. That's why you see here. Still, if you're looking for a few more columns, we can add it. I take the job. Yes, I think looks like we deleted the job. Yeah, we deleted the job here. And I can. So this is the data set. Okay, final data frame. So if you want to save the data, so we can go and use a write API. Data frame name dot write dot format. Okay, so default is delta, and then even we can use other format as well. And the mode is important, because if table already available, it should not raise exception. For mode, we can use append or overwrite. Append means it will keep the old data, then it will insert the new data. Overwrite means it will delete old data, then it will insert the data. It's called append or overwrite we can use. Okay. Then save as table or save option. So we can go and save in a particular location. Consider if you want to save here, we can go and save the data in that location. Okay. So files, there I'll create a folder as output. So here I'll create a delta as a folder, and I'll create a same data in this location. Same data, I'll create a JSON file. So it's separate folder as a, sorry, mp underscore JSON. Same, I'll create a ORC file. Same, I'll create a Avro. CSV we already created that. Still, if you want to create a CSV, then create a CSV. Then option to header equal to true. XML. So Spark does not support XML directly. And when it comes to other formats, Spark supports other formats, like any delimiter file. CSV means maybe we are using a comma as a delimiter, but still we can go and use any other delimiter file. And once it's writes, we can find that location. Okay. So if you go to the output, which we can see here, all the format except XML, because XML directly it is not supporting here. Okay, that's why you'll see this exception. Spark does not support exception. We have to use third-party libraries. So that we'll see that later. Okay, so how to use third-party libraries? Spark does not support XML. No. This is about saving as a file. So we can go and verify here. We can find this Avro file here. See, Avro file, CSV file. Okay, delta table. This is underscore delta language, the delta table. JSON, ORC. Okay, these are different formats. We may get any formats and we can write any format, but just consider if you want to read this. So how to read? Earlier we created a table, right? Now we created a file as well. Even we can go and create a file. Then similarly, we'll understand the partitioning. So save as table. How to create a partition table? How to create a partition table? So we'll go and use a save as table. So here we can use a partition by separator. Option is available. Then we can specify how many columns you want to specify here. So consider I want to create a partition on department number or maybe job. Okay, even we can specify multiple columns or one column. Partitioning is not suggested to go with a more than one column. Mainly if you are going with the year and month, that is good, but not for suggested for other columns. Okay, because it will create a more subfolders. We'll see that. So we don't have this table. I think employee underscore part. Yeah, this table just we are trying to create. So we can verify here also. Table is available. And here also we can see the data. But what is the difference when it comes to partition table? Partition table difference, if you want to identify, first you need to look into the file system. So we can go and query file system. Whenever we create any table, default save as table, it will go and store inside the tables folder. So we can use %fs tables. You see here, separate subfolder is created. Department 10 separate subfolder, department 20 separate subfolder, department 30. Each subfolder, it will have a data file. Now this subfolder is having one data file, market data file you see here. This is complete location. Okay, ABFS location. This is ABFS location. This is a file name and this is complete location. File name and complete location, which you can see here. So what will happen whenever we go for creating a partition table? Like we'll create I think a job. We don't have a job in the data frame. We delete it here. Let's say we create the job. Now, if I create a partition on job, I create another table. Okay. What will happen? It will create a table, but inside the table, it will create multiple subfolders based on the job values. So analyst data, it will store into this subfolder. Plus data, it will store into subfolder. So every job value, it will create a subfolder. You say this 1, 2, 3, 4, 5, 6. 6 subfolders it is created. So why it is created 6 subfolders? Because it is having a 6 values. That column is having a 6 values that it will split and store the data. So partitioning is good only. It will split and store data in subfolders, but it is not good for smaller tables like this. So minimum, the table should have minimum 1 TB data. So remember, partition should be created for larger than 1 TB table sizes. Okay. So we should not go on to create a partition table for smaller tables. We should not create partition on smaller tables. So we can use cluster by for smaller tables. Cluster by, instead of partition by, we can use a cluster by. Cluster by is also another option. Let me show you that. So whenever we go and verify this table, you see subfolders it is created. Clustering, it won't create any subfolders. But before that, there's a command to verify. Describe extended. You can go and verify the table. It will show you the columns and data types and the partition column. You see, this is the partition column. The table type, where it is storing that information also, which you can see here. Describe extended. Table type, it is managed table. The location where it is storing. And the provider, it's a delta. And the partition column and the data type. And other columns here, so you can see here. Okay. In high, we have an option called show create table. Show create table name. So that feature, when we look at to understand the DDL means columns and data types. So they're not allowing here. You see here, this command is not supported. That feature is still, it is not available here. But you see still some information you see here. Even if it is raising error, where it is storing the catalog name, Spark catalog, database, which is our Lakehouse database, the table, and then type and the properties. So still you see some information. Even if it is raising error, it is showing that information. Okay. This partition provider, which is table name, field information. So show create table is not working here. So create table is not working here. Still you can see this information, but the same information you will get from describe extended. Describe extended table name. Okay. Then you'll get that all the information. Okay. Where it is storing. If you don't want the columns, okay, just information, table properties, which location it is storing, describe detail. There is another option called describe detail. Describe detail is available. Just it will give you a format, every table where it is storing that location, table creation, and the partition column, and clustering column. The clustering is still we're not used. Mainly describe detail will help you for a number of files are available, size of the table, and the properties. Is the reason when to use this describe detail. If you want to know the partition column or cluster column, or if you want to know the number of files or size of the table, number of files which you can verify with this command, describe detail. Only describe will give you the only column names, data types, partition. If you want to know the other options, partition column, a table type, and other things, you can use a describe extended or a describe detail. So without column names, you will get a table location, partition column, cluster column, number of files, size of the table, table properties. So that information you will get. So now we created a partition and job column. That's why we see here the job column as a partition. Okay. Similarly, cluster by Pyspark level and SQL level. So it's initially a Delta is introduced that feature in only at SQL level, not at Pyspark level. If you use a cluster by, so they introduced only SQL level. So whenever we use a cluster by, it will raise exception use errors. But non-delta tables, clustered by is available. That is called the bucketing concept. Okay, this is high bucketing. Spark. Bucketing is a very old feature. That's the documentation. Search is not working here. Yeah. So cluster by class is available here, but initially they introduced only for SQL. But the latest version is available in both PySpark and SQL. Okay, that's the 5.1 documentation, and the latest version is 3.5.4 something. Let me verify this. Apache Spark documentation. If we go on the latest release, 3.5.5. This is the latest version. Okay. The cluster by was introduced the recent version, which is 5.3.1, but that was available only in a SQL. It is not available in Pyspark. Okay, Pyspark it is not available. And then whenever if you want to create a table, right, you have two options. You can use a save as table. If table is not available, it will create a table. Or you can create a table first, then you can save the data. You can use a SQL, then you can create a table. So create table name, and the columns using delta cluster by. So maybe a partition column or job column. So then you can specify all the columns. So let me show you available columns here. So these are the available columns. Employee number is integer. Or we can use the D types also. salary integer. Okay. So using delta, the table type, where it will go and create a table. Then cluster by. Partition by also we can use, cluster by also we can use. Partition by, cluster by. So when it comes to partition by, we can use in Pyspark. We can use, and let's verify any mistakes. It is not recognizing this syntax. Let's create a CSV file. Cluster by. Clustering should support here. Spark bucketing. So the Fabric also should support the bucketing. Delta won't support the bucketing. Okay, bucketing only non-delta tables. Bucketing. Hi. This is a machine learning related. Okay. Clustering is algorithm. Okay. Similarly, clustering is available for both. Okay. Latest version it is. Let me verify it. Get it. Okay. So we are using the latest version only. So cluster by. So cluster by is a bucketing concept. Let us not align here. Cluster. This is cluster, liquid clustering. Only delta only supports. So let us job is missing in that. So if you use a cluster by is bucketing, if you use a cluster by, this is liquid clustering. Okay. Which only Delta supports. And that's a new feature. But support here. Sometimes we see this issues. Just cancel and run it again. Yeah, now it's created. So let's verify. We'll insert the data. Where it is a data frame. Okay. Cluster by department number. But this syntax won't work here, okay? Because the table already created a cluster by. So this will work only with the latest version. Still, Fabric is not available with a 5.5, okay? 5.5.5. There's 5.1 only it is available, okay? That which we can verify in this. Say it's a 5.3.5. In the 3.5, multiple versions are there, subversions are there, okay? So there we have a multiple version. So Delta liquid clustering is available from the latest version, like 3.5 onwards, but only available on SQL, not in Pyspark. Pyspark they introduced the later. So delta.io, we go with the delta.io. Version, Spark version. This is not a Spark version, this is Delta version. Similarly, they'll have a Spark version as well. So this documentation is not available. So here also Spark version, it is not updated, but it is available from like a 3.5.5 it is available in Pyspark, but as SQL it is available older versions. At least SQL we can go and use like this. Pyspark they're not given any documentation, like maybe they're not updated that. It's okay. Okay. So partitioning and clustering. Partitioning is very old concept. It's not a new feature. Only this cluster by is a new feature. So you can't use in Pyspark currently. Maybe the latest versions once they release that will be available. Meantime, what we can do instead of using in Pyspark, we can create a table. Then we can avoid here. Maybe the table already created. Now we can go and save the data. Any columns which we missed? I think we missed one column. on the table level. It's the column total salary we are added. We can drop it and recreate it. This column is not available in the table. That's why it is throwing an error. Can you use a merge schema? Merge schema true. Any new column is there, that will be added. Or we can go and alter the table or recreate the table. Both are options. Both options are available. We can use a merge schema. Options. Now let's go and query the table. So cluster by Pyspark it is not available, but SQL it is available. Maybe it will be available in the latest version, like future versions, okay? In Fabric, but the Spark level it is available. So now we see the table, and then now whenever we go and verify, describe detail, describe detail, that's not showing here. Clustering columns. We created a same table, EMP cluster job. This table only we created. Let's describe next. It is behaving totally strange. Also, it is not there. Let's drop it and recreate again. One column we missed, right? Okay. So cluster means liquid clustering. Clustered means bucketing. Okay. Even it should support both here. Some values are there today. Let's write the data. Describe data. Overwrite as let's delete and create it again. Merge schema should work for only appending the columns. But the overwrite we are using for overwrite and merge schema, what will happen? It will delete the table and it will recreate the table. That was happened here. Okay. So whenever we use the overwrite and the merge schema, both combination, it will delete both. Means it will delete all the metadata and the data, then it will recreate. So here we don't have a cluster by option. That's why it is deleting. Even if we create a table, earlier it was deleting because of overwrite and merge schema. Okay. But if we use append mode, then we see this columns is available here. So cluster by is available only in a SQL. It's not available in a Pyspark. It's Pyspark whenever you are using. So we can go and create a table first, then we can load the data and so describe extended. Table properties. So which you can find the clustering is supported, which you can see under table properties. Okay. This feature. So describe detail will tell you that which column it is clustered. But up to 4 columns, we can go and create a cluster column to 4 columns. Yes, frequently we are using a department number, then salary column. Frequently, if you are using a filtering, then we can create a multiple columns also. But maximum it will support 4 columns. Maximum it will support 4 columns. So partitioning also same. We can go and create a multiple columns, but maximum suggested in is 2 only. Why we need to suggest only 2? Let me show you that example. If you are creating a partitioning, like where we have a data frame, yeah, here. So what I'll do, I'll extract, use a select expression here. Or maybe I'll use a with column. I'll add 2 more columns. I'll add 2 columns, here a separate column. So what I'll do, I'll use a date underscore format function on the hire date. I'll extract only year. Okay. Then I'll add another column as a month. So we'll extract. We can use the date underscore format. We can use the year and month functions also available. On hire date, we'll extract month. Then you will have 2 more columns. I'll show you that 2 more columns. Now you can see here year and month. If you have a null, then null will be there. It will get null partition separate. Okay. Earlier we created a partition on job, partition on department number, right? Now if you want to create a partition on this year, so you can go and create a year. You have month also. So if you want to create a partition on multiple columns, so we use this. We can use year, comma, month. So what will happen in the backend? So it will have a subfolders, multiple subfolders. Let me show you that. Today's just our focus is to understand Write API, only Write API. Okay, there's different options. Just understand the partitioning and subfolders. Okay. So under tables, it will create our table. Inside that, you will have a subfolder. First year is a subfolder. Okay, you say this. Inside that year, again another subfolder will be there, month. So 12 months data is there, but in that only 1 month data, December data is there. So 12th month. Okay. Similarly, if I go to another folder, it is having around 6 months data, January, February, March, then other like 8th month, 9th month, so August, September, November data. So in that again, it will have a subfolder. because 2 columns we specified will have a subfolders. Partitioning is not suggested for smaller tables because it will create a more folders and subfolders. That's why we'll suggest to create a partitioning only for bigger tables. Bigger table size is minimum 1 TB, then any size, maybe 2 TB, 3 TB, any maximum maybe any size, but minimum it should have a 1 terabyte data or at least minimum 500 GB data. So you can avoid this multiple subfolders concept. Okay. But always remember, if you are using these columns in the where class, then only it will give you the better performance. Then only it will give you the better performance. Partitioning also supports 4 columns. Cluster by also support 4 columns. But partitioning you can use in Pyspark, even you can use in SQL. Both you can use. The Delta supports both, but Fabric, when it comes to partitioning, supports both. Partition. So you can use an partition by any number of columns, but up to maximum 4 columns. But that is suggested only 2 columns. Don't go with the more 4 columns. Even if it is supporting 4 columns, we should not go with the 4 columns. So I gave example like extract year and month, right? We used a date format. You can use a date format, even you can use a date, year and month also available. Separate functions are available. It's a Spark SQL functions only. So you can use. And so if you want to extract, so you can take a current date. It will extract a year from that. So similarly, you can use a month. So it will extract year and month. Or we can go and use date underscore format. Both are same. Okay. Date underscore format advantage is same function you can use for any format. Maybe here we can extract year. Same thing we can use for extract month. This is specific functions to extract year, specific function to extract a month. But here we can specify the format. I want a date. Okay. Is 13th, so we can say the 13th. So date format also we can use, specific functions also you can use, but most of the projects will see country code, locations, year and month, okay, or even quarter also, year and month as a single. So a year and month as a single also some projects we can see. So how it will be like this. This one, year and month or year and quarter. So that we can extract and create a new column. Then that column we can give in the partition by. Okay. Similarly, cluster by you can use 4 columns, up to 4 columns. Even you can use 4 columns also. But partitioning is not suggested to use 4 columns. 2 is a maximum suggested because it will go and create a more subfolders. But cluster by is not going to create a subfolders. Even we'll see that table where we created here. This one, right? Tables. So this location, just you can find the data file. That's all. You don't see any subfolders concept. Clustering is not a subfolder basis, just a data. If you have more than 128 MB, so multiple files it will create, but nearby data, one file it will store. Nearby data, one file it will store. So clustering concept is simple. If you do the partitioning, normal blocks partitioning, or it will split the data and store data into subfolders. Let me show you that how clustering will work. Consider you have some students, okay? If you want to partition the data, okay? So if we give a partition, maybe a roll number. So roll number wise, every value, it will create a folder. Just I'm giving example, okay? Consider you have a student data. Consider 50 students are there, or maybe 100 students are there. What will happen if we use a partition by ID? Because frequently you will use a student ID for filter. So what will happen? Student ID is unique always because it's a primary key column. So you should not choose a primary key columns for partition. Means we have a concept called cardinality, high cardinality, low cardinality. So you should not choose a low cardinality. You should not choose high cardinality columns for partitioning. Consider, like, let's take employee table. So employee ID, email, okay, location, and the status. So let's take this as examples. In these columns, every employee ID will have a own employee ID and a unique email ID. It won't be repeated. But the location, same location, you can find multiple employees. The status also will have a two. That may be active employee or inactive employee. So when you look at these data fields, which is high cardinality, high cardinality means if number of rows and unique rows are same, that is called mainly called as high cardinality. Employee ID and email are always unique. Even if you take a distinct, the number of employees and distinct will be same. Because the email ID, every email ID will be unique always. Same email ID can't be possible for other employees, right? So this kind of data will called as high cardinality data. Similarly, low cardinality. Low cardinality means status. You can see if you have 1,000 employees in the company, but the status, if it like might be active or inactive. Okay, number of employees distinct will be different. The distinct always will be a 2. Distinct always will be a 2. Even if I have 1 lakh employees in the company, if you take a distinct of Y and N, only 2 only, active or inactive. So these kind of columns will create as low cardinality. If you create a partition on these columns, it will create only 2 partitions. If you create a high cardinality columns, it will create a more partitions, more subfolders. More subfolders also is not good. Less subfolders also is not good. Then we'll take a locations, which is normal, or you can say standard, medium cardinality, medium, or you can say normal. That is called location. So one location can have a number of employees. The company can have a number of locations. It consider take any company which is running maybe 20 cities. When you take number of employees, district, values, or location, always will be a different. But the distinct will be more than 2. More than 2. Like flag columns, we should not create a partitioning. Flag columns, we should not create a partitioning. Okay. Primary key column, foreign key column, unique key columns, then flag columns. We should not create partitions. We should not create a partitions. Okay. Then So partition, whenever you create, it create a subfolder, folder 1, folder 2, folder 3, n number of folders it will create. Instead of folders, if you use cluster by is file level. Okay, cluster by is a file level. File level means it won't create a subfolders, but file level only that data it will manage. Consider if you use student is having a student ID, student name. Just consider if you use a cluster by ID, cluster by ID. Okay, what will happen? Consider you have 100 students, so it will store nearby data in one place. Nearby data means maybe 1 to 35 students. It will store. It will store in one file. Then 36, 6 to maybe 65. 6 to 100. So nearby data means nearby students in one place. If you use a cluster by as ID, or if you use a cluster by as name, cluster by not a folders, it's a file. Cluster by name. If you use a cluster by name, what will happen? Maybe any person name starting with A to H, it will store here. Maybe I to or some characters, depends on the data. Okay, always at a size basis it will store one file. So each file size is 128 MB. Okay, just I'm giving a rough example to understand that how clustering will work. Okay, so any person name starting with the A to H, those persons will be available in the file 1, file 1, file 2. Okay, and UTG, the person student name starting with this name, it will be available. So whenever you query, right? So if you are querying a name basis, you will get a better performance. If it is clustered by on the name. If you store on ID basis, if you query ID basis, you will get a better performance. This is a storing mechanism. The difference between partitioning and clustering is not going to create a subfolders, but it is going to manage the data within the file, proper data. Means blindly, instead of storing a 1 to 30 students, it will store as a proper mechanism that column, whatever the column you specify. If you specify ID, it will store ID basis. If you specify name, it will specify the name basis, it will store. So whenever you are using ID in the where class, you will get a better performance. Similarly, whenever you are using a name in the where class, you will get a better performance. Even you can use a multiple columns also. We need to decide that which columns are frequently using. Which columns we are going to use frequently. So this is about clustering and partitioning concept. Partitioning is a subfolders. Clustering is not a subfolders, but data it will manage internally with the files. Nearby data in one place. That's a concept. Nearby data in one place. So based on the column, it will like a sorting, similar to sorting, but here we'll produce clustering algorithm. Okay, it uses clustering. So that's about cluster by. Cluster by we can use in only a SQL now. So first we need to create a table. Clustered by, I think still it should support. I don't know why clustered by is not supporting here. Clustered by is bucketing concept, which is we can go and use in non-delta table. Delta table, it won't support this one. This should be a non-delta table. Non-delta table means XCSV, Park, other formats which we can go and use. So cluster by you can use only in a SQL, but partition by you can use in both SQL and partition by you can use in the SQL. Here also the documentation already clearly mentioned this. Can use in a Pyspark. They're not given a SQL syntax here. So they're not given here as a SQL syntax, but yeah, you can use in both the SQL and Pyspark. Go to the documentation also. So it's clustered by. Clustered by is a bucketing concept, but non-delta tables. Non-delta tables means which you can go and use as other formats. Non-delta tables. And partitioning, we can use both tables. So this will go as a bucketing concept. It's a old concept. Now we are not using clustered by, we are using cluster by, which is delta feature. Bucketing is very old feature from Hive, but the same feature still it is supporting for other formats, not for delta table. So we can go and use it looks like they deleted here. Let's verify the data frame. Yeah, they deleted here. Okay, latest version they deleted. Bucketing they deleted here. It's not available in the latest version. Which we can find the right API. Like we look at this partition by. This is partition by. This is not a cluster. So SQL it is available cluster by, not clustered by. Clustered by is a bucketing concept. So that is a different class. So yeah, this is about bucketing and bucketing means a clustering and partitioning concept. So partitioning, we can decide bigger tables, and cluster by we can decide smaller tables like less than 1 TB tables. But currently we can't use at Pyspark level. First we need to create a table like this. Then only we can go and use that. Okay. We need to create a table. Then we can go and load the data. But we need to avoid that merge schema and override. What will happen? It will delete and recreate the table. Append means it will allow, but override what will happen? It will delete. If we use both combination, override schema and override and merge schema, these two combination, it will delete the table and it will create a table. Okay. That time your table will be deleted and append, merge we can use. So only at table level it is available. At the latest release, it is available in Delta, but still it is not available in the Fabric. But still we can go and create a cluster table in Fabric, Delta table with a clustering, Delta table with partitioning. So both we can decide based on the requirement. Should be like smaller tables, the bigger table concept. Any table which is less than 1 TB, use a cluster by. Greater than 1 TB, use a partition by. This is about Write API and Delta anyway, Delta features and Delta, what is Delta, how it will store that anyway, next week we'll see that. And just to want to understand the Write API part, like yesterday we used other options also. Save as table, save option. So save means it will go and save in a specific location. Save as table means it will go and store in a tables location. Tables, save means files. Save as table means in this location. Save means a file's location, any path which you can specify. That's about to save or save as table. And mode overwrite and append. Another one is we can use a merge. SQL also we can use a merge. Pyspark also we can use a merge. Only Delta table we can use merge. Other tables we can't use. So tomorrow what we'll do, we'll understand the JSON. JSON is very important. Similarly, read API for other formats also. So read API for var, say Avro. So how to read those formats. Earlier we created, but not understand the read API. Now we'll understand the read API. JSON is very important. Tomorrow what we'll do, we'll understand the JSON part. Then the read API and the write API and the transformations will be done. Then we'll understand the Delta table. So when it comes to any ETL projects, right? How we'll use a Spark. Spark as a ETL. You can extract data, apply transformations, then write the data. So just we started with only CSV. So how to create a data frame, then apply the transformations. That is read API is for extraction. Then we apply the transformations. Your transformations will be same. It doesn't matter your source, maybe any source. Once a data frame is created, right? Your data frame may be from in a read API. So it may be a CSV, maybe a JSON. So any read API. Then write API. Write API is nothing but a data frame dot, right? Then format. But in here Fabric always will prefer Delta because Delta is having more features. So your read API, maybe any file you can read. Your transformations will be same. And the write API is only one write API will use, but still you can write other formats also, like we written other formats, CSV, JSON, okay, or say other formats also. So Spark as a ETL. Extract. Extract is nothing but read API, transformations, then loading. Loading, or you can say writing or saving. So how to save the data? We can use the save as table or save option. That's a write API. So write API, the read API, then transformation. We went through all this, but read API, we started only with the CSV. We went through all the CSV options. Then JSON also very important. We may get a JSON files also. If it is a traditional ERPs, we'll get a more CSV files. But APIs, they'll send the JSON files. So tomorrow what we'll do, we'll understand the JSON as well. So once we are good at read API, write API, the transformations, then we'll move on advanced topics and the projects. Okay. Any questions? Okay. Okay, then See you tomorrow. Thank you.
Thank you, Ravi.
Thank you.
Yeah, thank you. See you tomorrow.